So this is just sort of Murray's rules of vectors, and I don't know. I thought we'd just talk about a little bit what they are maybe before I try to like do stuff with them. So concept 0 is that a vector is anything that has a magnitude and a direction. Okay? So for example, 8 centimeters in the x direction is a vector. 8 centimeters is how much, and in the x direction is the direction. Yeah? So those things on your little map, these things were vectors, weren't they? These things were vectors, weren't they? Huh? Yeah. There you go. And this guy's also a vector, 18 centimeters at 320 degrees. As long as we all hold our protractors the right way, then this is an absolute direction, yes? Okay? And if you hold them the way that you wanted to do that, right, with north up the page, right, then that is how actually orienteering, that's how Boy Scouts do it, right? When you read a map, and as long as we all agree that north is north, then we're in good shape, right? Okay? And then we could also have, it's not just displacements that can be vectors. You can also have vectors that are meters per second. You can have forces, that's a force vector. Anything where you care about the direction can be a vector, and in physics it almost always is a vector, right? Now examples of things where we don't care about the direction, or it couldn't have a direction, is like 5 kilograms of water. What direction? Well, it just is, right? Or how about 22 degrees Celsius? Which direction? It couldn't have a direction, right? Some things can have a direction, or we can not care about it, right? Like, go run a mile on the track. Well, probably if you run a mile, you're going to end up almost in the same place, right? Yeah? If you run a mile and do laps, you're actually 9 meters from where you started. If you run a full mile, that is, you go 9 meters more than 4 laps, right? Okay? So that's just distance, but if you displace yourself a mile due east, then that's a vector, right? So sometimes we talk about things in two different ways. Yeah?
The vectors are sweet, but what's the German phrase of the day?
Oh, German phrase of the day? Du kannst so schnell wie mich fahren. Du kannst so schnell wie mich fahren. Fahren. So schnell is speed, so fast. You can as fast as me drive, is how you say it in German. In English you'd say you can drive as fast as me. I said this, there's a German boy that lives across the street from me, and his parents are both German, and well, one of them's Austrian, one of them's German, and they speak German to him, right? And so I backed out of the driveway, and he was booking down the street on his bicycle, and I leaned out the window and I said, Charlie, du kannst so schnell wie mich fahren. And he looked at me like, you speak that language too? And then he said something in German that I wasn't sure about it, because he said it very quickly. And yeah, you know. I think he said yeah or something, I don't know, you know. Okay, so now that you know what a vector is, there are 3 handy truths for vectors. These things are all true, these things are all handy, or I wouldn't tell them to you. And I wouldn't call them handy truths. Okay? So truth number 1, if you want to reverse a vector, and this is kind of cool because you guys already knew this. You don't think you know this, but you actually know this. If you want to reverse a vector, multiply by -1. So on the sheet, when it said 8 centimeters x, you guys drew to the right, didn't you? Some math teacher taught you that. It had to do with number lines. But when it said negative 8 centimeters x, you drew an arrow going to the left, didn't you? Yep. Didn't you? Yep. There we go. So positive vector A, negative vector A. Whoops. No, they're both vector B. Positive, negative, right? Or even any vector, this vector would be positive, this would be its negative. Positive, negative, positive, negative. Yeah? Positive, negative, yeah? Okay? If that's positive some vector, if vector A is negative 3.5 centimeters in the y, the negative vector A is actually positive, right? Variables are funny that way, right? There we go. Yeah? This is pretty simple. Isn't this simple? So let's do something harder. You guys ready for harder?
No.
Yeah, you are. Let's suppose we are going to add...
Wait, can you go back? Just a second. I didn't get the... Oh, never mind. Left to Megan.
Are we good?
Yeah.
Megan's not good?
No, yeah.
You're good, okay.
Get those.
Okay, next one. Now we are talking about adding vectors. There are two different rules. One is for vectors that are parallel. This is the easiest rule. These guys are parallel or anti-parallel. It's just as easy. Yeah. There's a difference between this and this, isn't there? If they're vectors, there's a difference, right? If they're lines, they're both parallel, right? Yeah. But with vectors, this is different from this. I always get some kid that always argues, no, they're the same. It's like, no, they're not, right? You know, when you get on the freeway, you want to go the same direction as all the other cars, right? Every now and then somebody does this, though, right? They get on the exit. They're probably like, you know, just totally stinking drunk, right? And they get on the wrong way and then they kill somebody, right? And they can go miles. They can go for miles. You guys ever hear that joke about the lady whose husband is driving on the freeway and she calls him up, right? And she goes, honey, be careful. I just saw on the news there's some idiot driving the wrong way on the freeway. And he goes, one idiot? He goes, there's hundreds. So an example of this is if 8 is 8 centimeters x and b is negative 3 centimeters x, you guys would all be, I believe, you already knew this one too, you guys would all be smart enough to say that that's just 5 centimeters in the x? Yes. Yeah. Notice how we added those by just adding them, yeah? Yes. This is called scalar addition. The ordinary stuff that you did before you ever knew what a vector was called is called scalar. So this is the scalar sum. Yeah? And what we're going to do by the time you're done in this day and the next day is you'll be able to do the vector sum of two things. Okay? So this is handy truth number 3. Are we ready for it? If you have non-parallel vectors, like not these guys, but these guys, if they are askew, but I didn't ask you, then you simply draw them tip to tail. Like that. So you place them tip to tail, and the sum of the vectors is the better set of directions. Can we not write on whiteboards? Can you put your whiteboard pen away, Jen? Yeah.
Are you telling us not to write out?
No. Yeah, no, take them in your paper, please.
I'm taking the bigger notes.
Okay, so if you draw these guys, if you draw this thing, right, A is like this, then you draw B off the end of it, A plus B is this guy. Never mind that A plus B is shorter than, shorter than A, right? You know, vectors are weird that way, right? Okay. Now, does it matter, is A plus B the same as B plus A? If I drew B first and then drew A, would I end up in the same place? Yeah. And this is, at least for two vectors, this is a semi-rigorous proof. That's just a parallelogram, right? These sides are congruent. And if those sides are congruent, then you have to end up in the same place because, yeah? Oh, you'll see. You'll see.
I still have no idea where you're going.
Oh yeah, you'll find out. I promise. Humor me for 2 classes and then you'll see. Because when we need to solve problems where we launch things into the air, it's like this, right? And so that velocity vector has a little bit of horizontal and a lot of vertical. And you've got to be able to figure that out to solve those problems. How's that? Okay, so you place these guys tip to tail. A plus B is the same as B plus A, so it is actually commutative. Okay. If you want to subtract B from A, you'll read, I think sometimes you read it in the textbook, they'll have you put them tail to tail. Don't ever do that. Just go B minus A is the same as B plus, or A plus a negative B, right? So A plus a negative B looks like that, right? So here's A, here's negative B. Never mind that negative B is up, vectors are weird, right? Here's A minus B.